we have a trigonometric equation and we're being asked to write it in a different form. Now, we could either start with this and try and get to this, or because they don't look anything alike and we've got addition formula here, it's very tempting. And I think the best thing to do to actually start with the thing we want to prove and just like manipulate it a little bit and see if we can actually get back to this one because this is a bit harder to expand. And then we can just say, hey, we will do the steps in reverse, or we can actually do the steps in reverse. So sine 2x is 2 sine x cos x. That's one to know. Right, but sine 60 minus x, well, we have sine a minus b is equal to sine a cos b minus sine b cos a. And so here we're going to get that it's equal to sine 60 cos x minus sine x cos 60. Sine 60 is equal to, it's root 3 over 2, and cos 60 is a half. So that means we can multiply, I would multiply 3 by 2 at this point to give me 4 sine x cos x equals root 3 cos x minus sine x. Now at this point, we need to sort of think, right, where are we trying to get to? We're trying to get to this formula here. And so if we're doing the steps in reverse, you know, basically we need to get to this and then we can say, let's do the steps in reverse. Now it might be very tempting to divide through by cos now to get a tan in there. However, we also need a 1 plus 4 cos x. And if you divide through by cos, then that cos will go, that cos will go, and we'll be left with tan. So actually, there's a little intermediate step we need to do. And that is to write 4 sine x cos x plus sine x is equal to root 3 cos x. And if we now factorize out the sine x, then we get that 4 cos x plus 1. And we're essentially there, in fact, because I can now write down that sine x will equal root 3 cos x over 1 plus 4 cos x. I've just flipped it around because that's what it's like in the answer. And finally, divide through by cos. I feel like I can just say, therefore, the two equations are equivalent. And the result follows because I can take this and I can write it in the other form. If you really want to just be sure that you're going to get the marks, I feel like you should, then I could reverse the steps. I'm just wasting time here though, aren't I, really? So I wouldn't do this. If you're doing this paper, I would do this right at the end. And then I would times through by cos. Okay, there's going to be one more, more than one way of doing it, but I'm just going to do it the opposite to how we did it. And it's a bit clearer now because I remember the steps and everything we did. And then it was then we can divide through by 2. say that that is sine 60. Divide this one by 2 as well, and say that that is cos 60. And the result will follow from this. Therefore, sine 2x is equal to sine 60 minus x. It's not, I don't think it's as clear to, if I hadn't done those first steps, it wouldn't be as clear to get to here. So I honestly still think that doing it my way is the best way. It's just whether you should then show the parts in reverse. Okay, on to part B, which asks us to solve this original equation. And A gives us some massive hints. Basically, we don't want to solve this. We want to solve the equation that just involves sine, which might be something you've never ever seen before. But this one, what can you even do with it? You can't, you got a cos and a tan and all this sort of stuff. Whereas at least this one, you've got a sine and a sine. So one possible solution would be to actually take inverse sine and just set the the 2x equal to 60 minus x. That means that 3x is equal to 60, and so x is equal to 20. And that is a solution. But it's not the only solution. You can't expect to just get one solution. That would be quite straightforward, wouldn't it? There's going to be more. It's just how are we going to get these other ones? Now I'm going to do it from two viewpoints, or at least I'm going to talk about it in two different ways. The first thing is how many solutions are there? Okay, that is one question. The second is how do we get them? And I just want to remind you, like if we're solving something like sine x, I don't know, equals 0.1, you would get a solution here. And then another solution, I'll go straight to this one, would be to add 360 onto it. And we can still do that here. When we take inverse sine, you can imagine that if you added 360 onto one of the sides, then it would still give you a solution. So second solution is going to be 2x equals 60 minus x plus 360. And that will give us 3x is equal to 420. And therefore x is equal to 140. And we found a second solution. Um, you could substitute it back in. Would that work? And see, sine of 280 is equal to sine of what was it? 60 minus 140 minus 120. I mean, that does work because you can see that you just add on 360 to this to get it. So it will definitely work. It's just whether I've convinced you. Now, why not add 360 to both sides? Because then we'd just get the same solution as before. That wouldn't help. Why not add 360 just to the left-hand side? Well, actually, we'd get a negative solution there. It wouldn't be in the range. 2x plus 360 is equal to 60 minus x. I mean, this would be a solution. We would get 3x is equal to minus 300. So x is equal to minus 100. We'd have to reject that one. There is, one that you might consider. So just to summarize this so far, okay, instead of, I've taken inverse sine, but I've actually said, well, another possibility would be if you have, this part on the sine curve, but you added 360 to it. So that's what I did, and that will get us x equals 140. And we can see we're close to the, the limits here. So if we added on another 360 for another one, that wouldn't be in the range. This just leaves one solution to find, in fact, which is going to be this one here. Let me do that in a different color. Okay, so far I've convinced myself I've got this one. I've added 360 on and got this one. It's very close to the upper limit, so I'm not going to need to do that again. What I am going to need to do is look at this situation. And remember, to get this one, normally you do 180 minus x, and that's exactly what we're going to do here. Whatever value I have here, I'll do 180 minus it. So if this was A, then another solution is 180 minus A, using the symmetry of the curve, because that point is 180. So our third solution is going to be 2x equals 180 minus this 60 minus x. And that will give 2x equals 120 plus x, and therefore x is 120. And we've got a third solution. How do I know that I've got them all? Is a question I hear you asking. Um, and this comes on to my second way of thinking about this problem, and that is to plot or sketch y equals sine 2x, which is actually quite quick to do because it is just going to be y equals sine x, but now it's going between 0 and 180 rather than 360. This 2 will stretch sine x by a factor of a half in the x direction. And then in blue, slightly trickier one, is going to be y equals sine 60 minus x. And to sketch this one, I don't really like it when there's a negative in here, so I would personally use the property that sine of minus x is minus sine x. It's an odd function, and I can write it as x minus 60. So little sort of practice sketch. If I want to plot without the minus, if I want to plot y equals sine x minus 60, then it would be sine x, but it would be translated by 60 degrees. So it would be like this, and it would come down like that. And that would approximately be 360. So I guess I'm going to be hitting probably here for 180. And therefore, if I plot the negative of that, I'm just going to reflect it in the x-axis, and it's going to maybe start here. It's going to put a few points on. Then it's gonna come down. So yeah, I might draw that bit on, and then it's kind of going to go. It's hard because I'm suddenly stretching it, aren't I? I think I'm going to do that again. I think it's going to look a bit like this. And then maybe a bit like that. So I'm going to get a solution here. That's my 20. I'm going to get a solution here. That's my 120. It's after 90, which is where this purple curve would cross the axis. And I've got another one that's 140. Okay, it's not perfectly to scale, but I've kind of convinced myself that there's three solutions. There's not going to be another one. This is not going to be coming back up. And so we can happily sit there and say we found them all.